Hello, another AQA A-level Physics multi-choice question. To choose a different question but from the same topic, click on the information badge up here and that'll take you to the playlist. Okay, if you want to try this question yourself, I suggest you pause the video now. If you've got the answer the answer A, which is 5, well done. If you want to listen to my explanation, keep watching. So monochromatic electromagnetic radiation of 5.8 times 10 to the minus 7 meters is incident normally on a diffraction grating of 3 times 10 to the 5 lines per meter. What is the highest order maxima produced? So we've got a diffraction grating and we've got some light hitting that diffraction grating, and that light is going to be diffracted as it goes through and it's going to form bright spots or maxima. One is going to be straight through, we call that the zero order, and then there'll be ones at different angles. There'll be the first order, the second order, and eventually we'll produce orders where that angle theta is greater than 90 degrees. If it's greater than 90 degrees, then it's actually not possible to produce that maxima. So the largest maxima that is possible is the one that is produced before we reach an angle of 90 degrees. So let's look at the equation on the data sheet we're going to use to help us solve this. It's the spacing between the lines, d, on the grating, multiplied by the sine of that angle, is equal to the nth order, 0, 1, 2, 3, etc., multiplied by the wavelength of the light. And what we're going to do is we're going to use sine of 90. We'll find what nth order we get when we have 90 degrees, and it'll be some decimal, 2.8, 2.9, 5.7, whatever, and then the maximum, the biggest order that we can actually see will be the one smaller than that, the whole number smaller than that decimal. Okay, slight problem is they haven't given us the spacing between the lines. They've told us how many lines there are per meter. So the first thing we need to do is work out the spacing of the lines, which is going to be 1 over the number of lines per meter. Put that into my calculator and I get an answer of 3.33 times 10 to the minus 6 meters between each line. Okay, let's rearrange the equation to give me n. The nth order is equal to the line spacing multiplied by sine of the angle over lambda. Well, sine of 90 degrees is going to be 1, so it's going to be a nice easy calculation that I need to do. So d, we've just worked out, is 3.33 times 10 to the minus 6 meters. I'm not even going to bother writing sine of 90 because I know it's 1. Lambda is the wavelength of the light, which we were given as 5.8 times 10 to the minus 7 meters. Put that into my calculator and I get a value of 5.7. Well, 5.7, that's the one at 90 degrees. These have to be whole numbers, so the number that's smaller than 5.7, i.e. 5, will be the last order that is possible to produce. The answer is A. I hope you found this video useful. Hit that subscribe button, share the video with other people, and give me a like, and definitely come back and watch more of them. Thank you.